Welcome to section 6.6, the final section of the chapter. This is all on solving systems of linear equations. Of linear inequalities. 6.5 and 6.4, actually the rest of the chapter are all about linear equations, but now we're working with systems of linear inequalities. So we're going to be graphing two different inequalities and then figuring out what is the solution when we have multiple sets of inequalities. So I'm going to graph this first equation first. So I can see from that we have a y-intercept at -2 and a slope of -1. So from there, we will actually, let me just continue that down just a hair. So it'll go down 1 and over 1, or down 1 and right 1. Or, so we don't keep going off the board, we can also go in the opposite direction, which should be up 1, left 1. And then up 1, left 1, up 1, left 1, up 1, left 1. And remember, since this is an inequality, since there is no equal sign underneath that greater than, we need to connect these dots with a dashed line. Now, for our second equation, a second inequality, we have a y-intercept at 6, so 1, 2, 3, 4, 5, 6. And our slope is 3. So we can either go up 3, 1, 2, 3, right 1, or I can go down 3 and then left 1. So 1, 2, 3 over 1, 1, 2, 3 over 1. And since this one does have that equals line underneath, this one will be a solid line passing through those points. So we've got those. Now, how do we figure out what area do we shade? Well, one way you can do it is sort of that guess and check method where you just pick a point and see what happens. Before we do that, let me just explain sort of what your answers will look like. So these two lines intersect and turn your graph into 4 new sections. You have this section up here, you have this section down here, you have this section over here, and this section over here. So the 4 quadrants basically off of those 2 intersecting lines. So we need, one way that you can do this is you can just pick a point in any one of those sections and see if it works. So say we pick the point 0, 0. Well, -0 minus 2 is going to be a -2. And is -2 less than 0? Yes, it is. So it actually worked. And if it worked for one system and it's clearly within that quadrant, that means it will also work for that other system. Wait, no, I take that back. That does not necessarily mean it will work for that other system. All it means is that off of that first line, you are on the correct side of that line. So we have narrowed it down by you using that in relation to this line. So what that tells you is it's either going to be up here or over here, because we know it has to be above that line. So now we can go and check the other equation. So 3 times 0 is 0, plus 6 will give us 6. Is 6 greater than or equal to 0? Yes, it is. So now we can say for sure it is going to be this section. For me, I don't like that method of solving it. It just takes too long, and there's a faster way to try to solve this instead. So what I generally do when I'm trying to solve this is I just look at what are the sentences actually saying. So our first statement says that we are looking for y values that are greater than the line that we drew. So y values that are greater means we're looking for y values that are up from that line. Well, up from the red line means it's going to be either this section or this section, because those y values are both up from that red line. Now, the second equation says we want y values that are less than or smaller, in other words, under this purple line that we drew. So if we go to the purple line and we want to go for y values that are less than that, you can just go straight down. And you can even draw an arrow straight down. And that will tell you, oh, it needs to be on that side of the line, but it needs to be straight up from the red line. So it has to be this section. And I like that sort of logical reasoning system faster, just because it takes less time for you to figure out what section do I shade. So let's go and try this next one. This one is tricky because we're going to have 3 different lines here. So the first just says that our y is greater than or equal to -1. Well, our y equals -1 is this line. It is the horizontal line through -1. Since it is greater than or equal to, that means it will be a solid line. And if you really want, we can actually evaluate this now to figure out what side of the line do we shade. Well, since it's greater than or equal to -1, we want y values that are greater than -1. So that means they're going to be above that line. So our answer has to be above this line. Now the next one is x is greater than -2. Well, -2 is going to be right here, and it's going to be that vertical line straight down through -2. And our x values have to be greater than that. So if you think about just your regular number line, x values being greater means we're going to the right. So x values being greater here also means we're going to the right. So it needs to be above the purple line, to the right of the blue line. And now let's figure out what the heck this last line is doing. So if we go and subtract x from both sides, we'll get a 2y less than or equal to 4 minus x. Divide both sides by 2, we get a y less than or equal to 2 minus 1/2 x, which in slope-intercept form would be a -1/2 x plus 2. So that means we'll have our y-intercept here at 2, and then our slope is -1/2. So we go down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, or up 1 over 2. And this does have that or equal to line with it, so that means it's going to be a solid line. And with this one, we want y values that are less than that line that we just drew. So that means we need it to be below that line. So we need it to be below the red, above the purple, and to the right of the blue. So the only answer that works for all of those is going to be the inside of this triangle. And that would then be your answer. Let's try another one. This time we're going to want to write a system of inequalities for the shaded region. Well, the first one that I'll look at is this horizontal line that's going through this point, which is y equals 3. So that line would essentially be y equals 3, but we have to remember it's an inequality. So that means we need to say what side do we want it to be. Well, we want our y values to be greater than that amount because that's the shaded purple region. So that means y has to be greater than or equal to 3. Let's make that a little thicker. There we go. For the other one, let's just think about this with slope-intercept form. So this is an y equals. Well, our slope to get from one point to the next, we're going up 1, 2, right 1. So up 2, right 1, x plus our y-intercept is right here at 1. Well, that means, in other words, this would be a y equals 2x plus 1. Now, what we want is we want it to be the y values that, well, is this going to be above or below the line? Well, if we think about this point right here, the purple section is above that line. So we actually need y values that are greater than that 2x plus 1. So y has to be greater than or equal to 3, and y has to be greater than or equal to 2x plus 1. And to take that back, because this is a dashed line, so it will actually be a y is strictly greater than 2x plus 1. We can't keep that equals mark in there anymore. So that's all the different types of questions they might throw at you in this section. So good luck, and let me know if you have any questions.